Hey! YouTube, thank you. I promise not to knock anything out this lesson. Good morning, guys. I will be with you in a couple of minutes. I'm just tidying up a lot of stuff I threw on the floor earlier, which was necessary at the time, but is now in the way. So, something to think about. Imagine you're standing in front of a mirror. Look down here. This bit where my finger's pointing. Imagine you're standing in front of a mirror. You take a step back. What does the image do? You wave your left hand. What does the image do? Feel free to like and subscribe whilst you are there. And feel free to head over to Facebook and say hi if you've got Facebook and you want to do that. Right, I'm coming. Ugh. Good morning, Maths Mob! Woo! Love Fridays! Love Fridays so much! Like, just always been my favourite day of the week. How are you? I hope you are good. Unless you were with me on Tuesday, which some of you may have been, this is the first Maths in Art lesson. Whoop, whoop. So we're doing Maths in Art for 7 weeks. 6 will be live. There's going to be 1, which I'll give you advance warning about, that's not going to be live because too complicated. I'm camping and I looked into like Wi-Fi options and stuff and I was like, oh, this is too hard. There'll be something that's not live that week. Don't worry about that for now. Today we are looking at symmetry through art. And yeah, I'm Ruth. I forgot to say that at the start. If you've not done these lessons before, hi, I'm Ruth. I'm a home educating mum and maths teacher. I don't work in classrooms anymore, just online with my home ed crew. So I've asked you to think about a mirror. You may have had a mirror to actually test this out with. I've found these ones, which are a little bit cracked, but we use them for various things. When you look in a mirror, what's happening to your image? If you move backwards, what happens to the image in the mirror? And then this bit confused me a little bit because I can't tell. When I'm looking at you, this is definitely my left hand. I'm rubbish at left and right, so I've checked. Got the L. That's definitely my left hand. But I don't know if that looks like it's my left hand to you or not. But if I'm waving that at a mirror, what does my image do? This is confusing. Like looking at that whilst on a video. Yeah, too much for me. So what happens? What happens? Should we have a think about that? Well, we've had a think about that, and we'll have a little. I've got some pictures that I created. Sorry, tech me. We just like occasionally we like get like this, but so often we just miss each other. Oh dear! Right, here we go. Look at my amazing pictures. There's a person with a question. What's going to happen when I step back to my picture, my image in the mirror? Oh, look, my person also stepped back. Well, in reality, they're not going to step out of the mirror. It's just that I was not good enough at tech to be able to get rid of that bit. So we just sort of have to ignore that bit and pretend it's not there. Yeah. Okay, so the image also steps back. It gets further away from the mirror. So if you get further away from the mirror image also gets further away from the mirror. And there's my little person waving the left hand at the mirror. What are they going to see in the image? The image is going to be waving back, but it's going to look like they're using their right hand. So it's on this side, but it's actually their right hand. I find this sort of thing really confusing. It blows my mind. I am not a naturally spatially aware person, but trust me, it looks like they're waving back with their right hand. It does, definitely. Basically, it's the same side, but because they're facing the other way, it's the other hand. Yeah, definitely. I've done a lot of thinking about that. And so what we've got there is something, we've got a mirror, and that's a mirror line. So a mirror line is a mathematical term. We've got the mirror, where it is, it's made out of glass and metal essentially, but that is your mirror line, and everything's happening around that. So that's where the reflection's coming in, and we can call that a line of reflection. It's where the reflection's happening. So where the mirror is where the reflection is happening. You can call it the mirror line or the line of reflection. So this is one object that's been reflected in a mirror. We've got some pictures for you from nature. I'm obsessed with linking maths to nature and art, because I really love nature, art and maths. What do you notice in this picture? So I've got a beautiful peacock, zebra. I can't remember if this is a moth or a butterfly now. I'm really annoyed with myself for forgetting that particular piece of information. And a moose. I didn't even check if that's like a moose or a yak or something else, but I'm going to say a moose. What do you notice anything about them? And with what do you notice? Like, there are no stupid answers, by the way. Well, maybe if you said I notice an elephant, there's not. Well, actually, maybe you can see an elephant. Maybe you can see an elephant. Stop looking for elephants, Ruth. But you know what I mean? Like, you can say something super, super obvious, like I can see some white on the screen. That's totally valid and true. What do you notice about these? So one thing I've already said to you, they're all from nature. I purposely chose them from nature. And you might notice they're all living animals. I've specifically chosen animals. You may also have noticed that there's like a mirror line in all of these pictures. There's like a mirror line, but it's a mirror line where it's cutting one object in two almost. So we call this a line of symmetry. So it's symmetrical. Nature's never totally perfect because there's things that can affect it, but you get this very, very almost perfect line of symmetry in many animals. So for example, with the moth or butterfly, can I call it a mothfly? If it didn't have this symmetry, excuse me, it's actually called bilateral symmetry. That's from me doing some research about nature and biology. It wouldn't be able to fly. It needs two wings to be able to fly. Similarly, the moose, the zebra, the peacock, they need two legs to be able to walk. And it all comes from the fact that things look attractive. Like we like looking at things that are symmetrical because we see it in nature. But you've also got things like scaring off predators. So like the peacock, this pattern is to do with scaring off predators. We've got the antlers, scaring off predators or defending itself. We've got the patterns on the zebra to help it camouflage itself. Maybe the fantastic pattern on here to attract a mate, and it all links to survival, essentially. All links to survival. So we don't always see bilateral symmetry in nature. There are examples of other types of symmetry that we're going to see later, and actually no symmetry at all as well. But it does come up a lot, and you see it in humans too. Okay, I've got a question for you that you're going to think about, please. I would like you to think about. You could do what you want. Whilst I talk to you about some art. So I asked you to bring some A4 pieces of paper. Grab just one of them now. I think I've said 4. I put a random number down. I didn't really know how many I was going to use, but you know, grab one of them. Grab a piece of A4 paper. How many lines of symmetry does this have? So I'm going to show you something here. I'm going to fold this. I've got the short edge at the top and the long edge at the side. Yeah, I'm going to fold it along the long edge, and I'm going to make the corners meet up exactly. Can you see that at the bottom there? I'm making them meet up exactly, and then I'm going to do a fold, and you can see that I've totally covered the back of that, and when I flip it around, there's no extra bits sticking out anywhere. So that is a line of symmetry. Yeah, so that's how I can find a line of symmetry there. I want to know how many lines of symmetry does this A4 piece of paper have? Well, you do it with yours. I mean, I'd try and give it to you, but yeah, I don't think I'll manage that. Yeah, you do that with yours. Whilst I talk to you about the type of art that I wanted to focus in on today, which is Rangoli art. I was researching this because there's so many examples of really cool famous artists that use symmetry in it, but this one just spoke to me because it's bright and it's beautiful and it's got a real cultural aspect to it as well, which I just thought was absolutely stunning. So I'm going to show you this. You continue thinking about your lines of symmetry in your A4 paper too. Rangoli art. Have you seen anything like this before? You maybe have seen something like this before. I've only ever seen it in pictures, never in real life. And you might, I'm just going to leave those up there for you. See if you notice anything, spot anything about those to start with. Have a little look, have a little think about those, and then I'll tell you a little bit about them. So I do find it, if you've not been to my lessons before, I find it hard to actually keep quiet. So I'm going to count 10 in my head without talking now. Okay. Wish me luck. Okay. So you may notice what attracts me to these is the very, very bright colours. They're absolutely stunning. But there is a lot of mathematics in this art as well. Lots of symmetry, like reflectional symmetry, which we've just been looking at. So that means it's like in a mirror reflecting. And this artwork is utilizes it to make it beautiful and stunning. Rangoli art originates from India. It's traditionally used to celebrate festivals. I think initially Diwali, which is the Diwali, I'm saying that, Diwali, which is a festival of light, but now I believe that it's used to celebrate many different festivals. It was traditionally done by women in the early hours of the morning. Again, that has expanded out and more people do that now, but it's done early hours of the morning at a threshold of the house. So I checked with my children 6 and 8, did they know what the word threshold meant? The 6-year-old didn't know. So threshold is like the entrance to the house. So it's to greet people and to say welcome, essentially. So if you've got like we use our back door rather, so we don't use our front door very often. So if it was me doing this, I would do this at the back door of my house to greet people at the threshold of my house. It's traditionally done with things like rice, flour, chalks, powders, actual flowers and petals, because it's not designed to last for a long time. The word is, and I'm not very good with words, so I've had to look up this. It's ephemeral. It's designed to be ephemeral, which means lasting just a short amount of time, and then it can be carried away by the wind. Animals may eat it, and lots of different things like that. So it won't last forever. Okay, so symmetry. How did we do with that? I've thrown my piece of paper on the floor, obviously, so I'm going to pick that up. I just get too excited. So how many did we find? So I showed you that one, didn't we? I'm going to call that like folding it horizontally, like along a horizon. Did you fold it vertically as well, like lengthways, like that? Did you? I'm going to say that gives me another line of symmetry like that. What about diagonally? Did anyone try doing it diagonally, like folding one corner onto the other? What happens when you do that? Oh, well, that doesn't look good, does it? Doesn't look good so far. But if I try to do it diagonally, I do encounter an issue, actually. What happens when I do it diagonally? Oh, no, it doesn't actually cover it up. There's bits sticking out, isn't there? So that is not a line of symmetry, not on my A4 piece of paper, because this is a rectangle. So I've actually only got 2 lines of symmetry. We've got the vertical and the horizontal line of symmetry on our A4 piece of paper. Now what we're going to do though, we're going to take a different piece of A4 paper and we're going to turn it into a square. If you've actually got a piece of square paper, that's fine too. So I'm going to show you how to do that. I'm just going to put this down on here to show you. So, because I'm not very good at folding in midair, I need like a hard surface to do it. All right. So if you've got an A4 piece of paper, you sort of take the one of the top corners. So I'm going to take the top right hand corner. Can you see me checking which is my right and left there? Top right hand corner. I'm going to fold that down to meet the left hand. No, top left hand corner, because you're the other way around to me, aren't you? Top left hand corner to meet the right hand side. And so that the very top edge is going to go along that right hand edge there. Yeah, so fold like that. So it looks like a triangle, and I'm going to cut that bottom bit off now. So we cut that bottom bit off, you'll be left with a square piece of paper. And then I'm going to ask you if you can tell me how many lines of symmetry are in a square using that piece of paper. So you just, that flappy extra bit at the bottom. I love a good non-mathematical term that I pretend is genuinely a mathematical term. The flappy bit at the bottom is, you just cut that off. And it looks like a triangle. You open it up, you've got a square. So what about the square piece of paper? How many lines of symmetry in that bad boy there? I don't know why I said bad boy. Just I needed to. So yeah, have a play with that. Folding that. You may have spotted one already. You may have spotted the we kind of created one. Did you? How many more lines of symmetry can you find in your square? So do that and think about this. Think about this at the same time. I hope you like twizzling around, because we do lots of twizzling in this lesson. Hope nobody gets car sick. So this is another example of Rangoli art. In fact, Rangoli is one word for it. My understanding is there's different words in different areas of India, so it can be called different things. So, but Rangoli is the word I'm using for today. Do you notice anything else about this particular piece of art, which is common to quite a lot of pieces of Rangoli art that I've seen? Do you notice anything else as well? So do your lines of symmetry in your square and think about this. Do you notice anything else about this particular piece of art or this picture here? We're going to try and incorporate this into our own little piece of art today. Do you notice anything else about this Rangoli art? I'll leave you with that picture for a second. And shall we have a look at our square? And then we'll come back to that. We'll have a look at our square. Right, so probably I gave it away a little bit for just by how we were creating this square, that we've got a diagonal line of symmetry this time, haven't we? In fact, we haven't just got one diagonal line of symmetry, we've got two, because I can fold it the other way and create a second diagonal line of symmetry. I'm going to have to do that on a hard surface though. So we've got two diagonal lines of symmetry in a square, as well as the vertical and horizontal lines of symmetry. So we have vertical and horizontal lines of symmetry also there. So there's my vertical and my horizontal. So it's actually got in the square, you've got 4 lines of symmetry, not just 2. So if we compare the square and the rectangle, the square, because all the sides are the same length, it lends itself to having more lines of symmetry because we can do those diagonal folds. Whereas the rectangle didn't have sides that were the same length, so we couldn't do those diagonal folds. Okay, keep those. We're going to use those again in a second. Particularly the square one's very important. Do not lose that. Do not lose it. Okay, so I showed you this picture here. And one of the things that came up on Facebook when I asked people to have a little think about this, if they noticed anything, they noticed like some sets of 3s. So there's like 3 flat like leaves here, and you can turn it around. There's 3 leaves here, 3 here, 3 here. The circles, there's 3 circles, 3 circles, 3 circles, 3 circles. They noticed that the leaves, we've got 3 leaves that we could rotate around onto themselves. We've got the stars behind as well that we could turn around. So this particular piece of art, it has reflectional symmetry, just like we were looking at before. So it actually would fit onto a square quite nicely. We've got reflectional symmetry, we've got vertical symmetry, horizontal symmetry, and diagonal symmetry here, if you ignore the fact that these are different colours slightly. Like, let's just pretend they're all blue or all green or something. But with the different colours, we also do have some, but not quite exactly the same. But it also can be turned around on itself. It can be turned around and create the same picture over and over again, which means it's also got something called rotational symmetry, which is another type of symmetry. It's not the one you can see in the mirror. It means that as you turn something round, you keep seeing the same picture. So you might think of like a wheel on a bike, a steering wheel in a car, something like that, when you can turn it around and it keeps looking the same as you turn it round. So for example, with my square here, I'm just going to do this on the desk as well, because it just makes it slightly easier for me. If I were to pin it in the middle here, yeah, if we call, let me do a little mark. I'm going to just do a little mark here. Is that the bottom for you? Yeah, that's the bottom for you. Cool. Do a little mark here. I can turn this shape around and it looks the same. It doesn't there. That's not the same, because that's now a bit of a, it's more like a diamond, doesn't it? But at that point, it's back to being a square again. And I can turn it around again and make it a square again. Turn it around again, make it a square again. And then when I turn it around one more time, I get back to my dot being at the bottom. So this can be rotated around 1, 2, 3, 4. Well, we've rotated it once, but it fitted into itself 4 times. That means that shape has got rotational symmetry of order 4. What about a rectangle? What do you think will happen with our rectangle? Try it out now if you want to. Put like your rectangle down. Put your rectangle down and put your finger like it's a pin in the middle and try rotating that around. How many times will it fit into itself before it gets back to the same place again? So if I put a little star here, so I know that that's the bit I'm aiming for to be at the bottom. What's going to happen with your rectangle? What do you reckon? I'll give you a chance to have a go before I just start doing it. Do not lose that square piece of paper, by the way. If you've just thrown that away, make sure you've got it again. I'll not be happy if you lose it. I'm joking. I'm laughing, by the way. I'm laughing. You'll never be in trouble. If you could find it, that would be helpful. So let's have a look at this one. So if I rotate this around, at that point it's not the same. It's a rectangle, but it's not the same rectangle, because I had the long bit at the bottom and the short bit at the side. Now I've got the short bit at the bottom and the long bit at the side, so that doesn't count. But when I get to the star being at the top, that is the same rectangle. Long bit at the bottom, short bit at the top, the side. Rotate it around again. No, not the same rectangle. And now my star's at the bottom. So that one only has rotational symmetry of order 2. It actually only fitted into itself twice. One when it was halfway round and one when we got back to the start again. I keep getting it caught on here. One when it got back to the start again. Okay, so have you got your square? Have you got your square? Sorry, I think I'm funny. My husband and my kids don't agree. So you don't need to do this bit, but I'm going to just show you this bit with a pen so you know what I mean. We had that square that we folded. I'm just going to highlight one of the sections. So there's lots of little triangles that you created. Can you see what I'm highlighting there? Yeah. We're just going to pop some paint on one section. So I said to bring some like thickish paint. I'm using what I call blobby paint. I don't think it ready mixed paint. I don't know if I'm supposed to advertise the product, but you know what I mean, that sort of stuff. And I'm just going to put some blobs of paint on here. I'm going to use 3 different colours. We don't want tons. Well, maybe you do want tons, actually. I don't know. I'll stop telling you what you want and you decide for yourself what you want. So on Tuesday's lesson, when I did this, I created like the creepiest clown face ever. And in all my practice ones, I made like beautiful butterflies. I'm aiming to get a beautiful butterfly and not a creepy clown face this time. So can you see I'm just putting some blobby bits of paint. Oh dear, that's not good, is it? But yeah, quite thick blobby bits of paint around in that section. Yeah, so I'm going to do that, and then what we're going to do, so some of you may have done this before. When I was a kid, this was quite popular. I'm going to put a piece of paper underneath because I've already got so many things on this desk and I got in so much trouble about it. We fold it in half. We start off by folding it in half along one of those lines. Doesn't matter which one. We just squidge it down a little bit. But now, unfold it and you'll get quite a cool picture, yeah? But we're going to carry on. We're going to go along another line of symmetry and fold it in half again. And do a little bit of patting, not too hard. And open it up. Look at that. Look at that. And then we're going to do a diagonal line of symmetry. Diagonal. And we're going to do a bit of patting. I like to sing random words. Sorry, guys, if you've not been here before. I've tried to turn it off. Apparently, it's impossible. So you just have to put up with it. Woo! And then you can do the other diagonal, but I don't think it make a huge amount of difference because you should have all the sides covered now. You can do the other diagonal just for fun, though. Okay, and then open it up. Ta-da! And hopefully you should have created a bit of art that has got both reflectional symmetry and rotational symmetry. Can you see? Like, I can turn this around. And it's got rotational symmetry. And there's no creepy clowns in sight. I'm well chuffed with that one. I'm well chuffed with that one. Look at that. That's more beautiful butterfly, don't you agree? Shall I show you? Do you want to see my creepy clown one? Do you want to see the creepy clown? It still makes me laugh. Look at the creepy clowns. Ah! It's like a rotating nightmare. Oh, isn't that awful? Yeah, I'll put that one back. I'm going to replace it with this one. I'm going to replace it with this one, which is much prettier. That's creepy. That looks much better, doesn't it? Yeah, we'll have that as my background now. I would love to see what yours looks like. If you want to send me a picture of what you've created, I would absolutely love to see it. We are not done. Do not leave. I've got more questions for you. Do not leave. Carry on painting. Listen to my questions. Oh, man. I love it when I'm in a silly mood, but I hate it too. But it's one of those days, right? Regular shapes. Have you come across a regular shape before? Of course you have, because we've just talked about squares. Regular shapes have all the sides of the same length. So a square is a regular quadrilateral. It's a regular four-sided shape. And these are regular shapes with different numbers of sides. They're called polygons, if you want the fancy word, but we don't have to use that. So we've got a regular triangle, which is called an equilateral triangle because they're equal in side length. Regular, that's got 5 sides, so it's a regular pentagon. Pent means 5. Regular hexagon, 6 sides. Hex means 6. And a regular, you can call this a septagon, or you can call it something else, which I always forget. What's the other one? Septagon or heptagon. There we go. You can call it septagon or a heptagon for 7 sides. What about these shapes then? Do they have any reflectional or rotational symmetry? So we kind of know about the square. I gave that one away, didn't we? I gave that one away. It had 4 lines of reflection and 4, it had rotational symmetry of order 4 as well. What about these other shapes? What do you think about those ones? Have they got any reflectional symmetry or rotational symmetry? What do you reckon? Have a little think whilst I have a sip of coffee. What do you reckon? Well, so I had lots of different answers on Facebook. Lots of people could see that the triangle, for example, has a line of symmetry going straight up, straight down, and they could see that with the pentagon as well. that there was certain lines of symmetry on there. I'm going to use my amazing drawing skills here, and you're going to just imagine that these look very accurate. Okay, so lots of people could see that with the triangle, that there is a line of symmetry like that down the middle. Yeah, so we could fold it in half like that. Actually, rotational symmetry could kind of help us with this, because look, if I rotate this around so it's this way up, can you see there's also a line of symmetry there? And then if I rotate it again, we end up with also a line of symmetry here. So because all these are regular, all three sides are the same length, it's got three lines of symmetry, and actually it's got rotational symmetry order 2 too as well. So if I put a little star up here, I can rotate this around, and it fits into itself once, twice, 3 times. And you can apply that. I'm not going to go through all of them right now. I'm going to leave you to explore that a little bit, because it's boring if somebody just tells you everything. But you might, if you explored all of those regular shades, got to be regular ones. You can Google some and print them off if you want to play with them. You might notice something about those with the reflectional symmetry and the rotational symmetry that I think is quite cool. I think it's quite cool. But you are allowed your own opinion. We're going to end today on a quiz. So if you've got the workbook, you have this grid in your book. I'm going to show you it. Don't panic if you've not, because I'm going to show you how you join in super easily just with a piece of paper and a pen. Okay, so the grid looks like this. The grid looks like this. It's got some words and some numbers in it, but you're not going to panic if you've not got that. We're just going to draw a quick 4x4 grid. We're not going to write anything in. We just cross off in the right places. Okay, so if you are using the workbook, you just find that. If not, what you're going to do is you're just going to grab a pen or a pencil, and I'm going to show you. We're just going to do a quick 4x4 grid like this. So you just do a little square. You cut it in half, both directions, so vertically and horizontally, and then each section gets cut in half again like that. So you've got a 4x4 grid. And I'm going to show you the picture. I'm going to show you the picture, and you just cross off the right square each time. Okay, so if I just turn you around so you can see the grid, and I'll just explain. So if, for example, and the first answer is not 4, by the way, but I'm going to use it as an example. If I said a question and the answer was 4, so that the 4 is here. So you would just cross off that bit on the grid. Okay. So question 1. A rectangle has 4 lines of reflectional symmetry. Is that true or false? If you can see the answer on there more than once, you can just cross off any of them. It doesn't matter which. True or false? So you can cross it off or colour it in. Okay, question 2. Rangoli art is traditionally ephemeral, meaning, so you've got to choose what ephemeral means out of this here. Okay, meaning, which of those words does ephemeral mean? So we've got false, true, morning, short lasting, 4, 5, true, blue, long lasting, everlasting, 3, bedroom, threshold, true, 2, false. Question 3. A regular pentagon has rotational symmetry of order. So think about the pentagon fitting into itself. This pointy bit, where will it fit into itself again as you go around? Question 4. All shapes, including this shape, have a line of reflectional symmetry. All shapes have a line of reflectional symmetry. Okay, question 5. Rangoli is traditionally done at the what of the house? Rangoli is traditionally done at the what of the house? And last one. Okay, so this one's a little bit confusing. You've coloured in 5 squares. I now want you to colour in one more square to make it so that your grid has has one line of reflectional symmetry, so one mirror line, and rotational symmetry of order 1. That means it will not fit into itself until it gets back to the start again. So it will never fit. It'll have to go all the way around before it fits into itself again. So I want you to colour in one more square to make it have one line of reflectional symmetry and rotational symmetry of order 1. Then I'll show you mine. Having one of those, have I overcomplicated this moments? Okay, right, let's go through these. So a rectangle has 4 lines of reflectional symmetry. That was false. So there was 2 falses on there. You could just colour either one in. That was false. Question 2. Rangoli art is traditionally ephemeral, meaning short lasting. So sorry, I'm going to turn this around so you can see where those were. So false was either here or here, short lasting down here. Okay. A regular pentagon has rotational symmetry of order 5. It fits into itself into each corner as it goes around. Question 4. All shapes have a line of reflectional symmetry. This one does not. That is not true. So you had to colour in the other false. So both the falses should be coloured in. Question 5. Rangoli art is traditionally done at the threshold of the house. And then you had to colour in one more square. So I'm going to show you. Oh, I am going to show you mine. Where is it? Here we go. So it should have looked. Let me just check. Yeah. It should end up looking. This is what you had when you coloured 5 squares in. So you could either have coloured in this one here to get the line of reflection down here, or you could have coloured in this one here, and you'd have had the line of reflection going horizontally. Some people on Facebook were colouring this one in here, which does give you a line of reflectional symmetry along here, but it also means that when you turn it around, it fits into itself at that point, as well as when you get back to the start. So it actually ends up with rotational symmetry of order 2. So yeah, that's why I was worried I'd overcomplicated it a little bit, maybe, we'll see. Don't know. Tell me, give me some feedback. If you're on Facebook and you want to say hi, there's a post there where I'm saying something like, Maths in Art starts in 20 minutes. I don't actually say it. It's a picture that says something like that in just that voice. You can go and say hi there, and I'll say hi back to you in a couple of minutes. these lessons are free to support my home ed community. We are a home ed family. We started off for home ed on a super low income. We really, really relied heavily on free help from other people. And I believe it's important to give back to our community. It's also my job, totally inspired by Ruth and Theatre of Science, where she makes it totally accessible to people to join in, but also makes an income from streaming live lessons. So if you want to, you can support me for £5 a month, and you will get my for activities booklet through the post, which gives you loads of cool ways to explore fractals, which are a really awesome area of maths, using hands-on ways, doing some engineering activities, doing quizzes and puzzles and things like that. That'll come with some origami paper and a little introduction to the Maths Mob Monkey and some cool funky stickers. If you want to support for £6 a month, you'll get that, and you'll also get my workbooks that you can download each week, which got space for you to do stuff in the lesson in, but also at the back, my sister-in-law helps with these now. She does some epic bits where you can explore it at home. So at the moment, you've got an artist to look at each time, and some other activities that we link to online that are all totally free to access, so that you can continue diving into this a little bit further as well at home. Did I need to say anything else about that? No, I didn't. I need to say hi to people on Facebook. That's what I need to do. That's what I need to do. Right, okay. Let's go and do that now. Oh, whoa! Hi, Ollie. We think it looks like nothing. I love that. I love that. You think it looks like nothing, but it looks cool. And maybe a flower? I see a flower there. Anyone else? I think it looks like a flower, like with purple insidey bits and yellow petals and some little green leaves. I'm gonna go flower. I think that's really cool. Really cool. Oh my gosh. What have you done to your dog? Oh dear. Mr. G has a cool hair. Is that a dog? No, it's not. Is it a dog? Sugarcane. Have I got another name for sugarcane? I'm going to say sugarcane. I'm going to say sugarcane, but I don't know if that's the right name. Tell me if I need to use a different name. But Mr. G, is Mr. G a dog? I'm not sure. Is it a hamster? Look at that. That's so funny. My dog absolutely would not tolerate that. That would be shredded in seconds. Like totally shredded. Hi guys, thank you for joining, including Mr. G. Ophelia's first time watching. Hi Ophelia, good to have you here. Loved creating your symmetrical art. Wow, those are two of my favorite colors. They are absolutely beautiful. I'm a big turquoise fan. If you watch me for long enough, you'll start to notice that because I wear it all the time. That is stunning, really stunning. Oh, thanks for sharing. Hi from Bella and her little cousin. Oh, hi. Amity, you might be my youngest viewer. Hi. You're excited for the lesson and you love the creepy. I'm glad you love the creepy clown. I've not showed the creepy clown to my kids because I fear what would happen. Who else have we got? Oh, your pack arrived yesterday. Chloe and Toby, awesome. I hope you enjoy it. We're still slowly we get the Theatre of Science packs and we like slowly work our way through them. Sometimes we have days where we do loads and other times we just do little bits of it. It's quite fun to do that. So yeah, Chloe and Toby, it's your first time watching live. Awesome. Lives are like my fave. I do appreciate some people just can't do lives, and that's fine. But I just love lives. So I'm so pleased to have you here. Hi guys. Sophie, Emily, Katie, and Hannah, you're back. Woo! 2 lives in a day. Good work, guys. Wow, you really enjoyed making lots of art and mess. Look at all of those. The blue and the yellow go really well together, don't they? Look at them. Aren't they cool? The blue and the yellow, like really contrasting. Very cool pieces of art. Hi, Connor. Hi. Who else have we got? Oh, wow. Wow. Loads of the pink. Wait. Let me just, is that Chloe and Toby? Chloe and Toby, that's epic. Look, we've got like a series of 3 different pink ones. Can you see? Series, oh no, it's not going to let me swipe. But they are very cool. That one, look at that for showing rotational symmetry. It's like a clock rotating around, isn't it? It makes me think of like a dandelion. Very, very bright dandelion. Hi, Indy. Hi, nice to have you here. Jacob. Woo, Jacob's always here. You're awesome. You're so on it, Jacob. Hi. Is it Hugo? Humphrey? Both of you? I really like your art. Tara, maybe? Really, really cool. That looks like a flower too. Or it makes me think of the hungry caterpillar. Look at that. It's loads of hungry caterpillars going round and round and round. How cool is that? Oh, guys, you've done some awesome art there. I love it. Absolutely love it. I will refresh just one more time because I hate to miss people. My kids absolutely love the saying hello bit. It's like their absolute favourite. So I just make sure. Oh no, it always refreshes in an odd order, so I never know whether I've done everyone or not. Let me just. I don't know why it does it. Why doesn't it just do it in order? Oh, Mr. G is a guinea pig. Right. Well, that makes sense to why it's not been shredded then. Yes, I see the guinea pig now. Yeah. Do you see what I thought though? It was like a dog nose just poking out. Does that make sense? Mr. G the guinea pig. Let me just check I've got everyone. I said hi to Connor. Yeah. Yeah, I think it was Humphrey. Thanks, Humphrey. It does look really cool, like proper hungry caterpillar. Like you should, like it could do with some little faces on. But it's your art. Don't listen to me. You do you. Thank you for joining me, guys. I totally love doing these lives. I am back next week doing. It's a surprise to me too. I've planned the lesson and I can't remember what it was. Tessellation? Should we say tessellation? Let's say tessellation. And if it's not, it'll be a lovely surprise for us all. Awesome. I'll see you next week. Bye.